Hello students, today we will continue with our previous lecture, Basics and Energy of the Atmosphere. We will move further uh, the atmosphere. In the previous lecture, we introduced the atmosphere. We studied how the atmosphere is formed, what is the composition of the atmospheric pressure, and the different gradients which include in the formation of the atmosphere. Today, we will move on with the next section of the chapter, that is atmospheric layers. Previously, we studied how the atmosphere was formed and what is its composition. In that, we studied that it is a combination of different kind of gases, water vapors, dust particles and components. These components carry different properties like density, pressure, electrical properties, chemical properties or temperature. So, you do not find all the gradients equally at equal altitude. The atmosphere is thus uh, divided into several layers. We divide the atmosphere into different layers, but there is no specific dividing line which separates one layer from the other. As we are talking about gaseous layers here, so you cannot pinpoint that from this level this layer stops existing and from here the next layer begins. So the division is very rough and they are not sharply defined, the boundaries, but still we are able to detect the different properties that different layers carry, and we have divided them into different layers. The first and foremost layer, starting from the closest to the surface, is the troposphere. Then we have stratosphere, mesosphere, thermosphere, and finally the last layer, exosphere. Although we do mention another layer beyond exosphere that is called magnetosphere, we'll come about that when we study exosphere. So we divide the atmosphere into 5 layers, and these layers, they consist of different features and different properties. Let's start with the first layer, troposphere. This layer is closest to the Earth's surface. The term troposphere comes from Greek background. Tropos, that means turning or mixing zone, and sphere being round in shape. As the name itself says, it is a mixing zone. Most of the gases present in the atmosphere are found in troposphere because it is closest to the surface. The impact of the gravitational pull is maximum on this, thus the maximum density of gases are found in the troposphere area only. The troposphere uh, carries gases like nitrogen and oxygen, which are maximum, then followed by carbon dioxide and water vapor and different uh, mm, dust particles. This is also the only layer where the climatic activities occur. The formation of clouds, precipitation, thunderstorms, cyclones, anticyclones, all the climatic situations are found in this tropospheric zone only. Thus, this zone is also known as convective region. Another important feature of the troposphere is its subdivision of the lowest part. The lowest part of the troposphere is subdivided into 3 sub-layers: the friction layer, the surface boundary layer, and the laminar layer. This is a very short area which affects the conditions close to the surface. The extent of the friction layer is around 1 kilometers from the surface. Then the surface boundary layer extends for a few meters, and the thinnest is the laminar layer, which only extends up to few millimeters. The last two layers, they are not of much significance. They are more or less stationary layers, but the friction layer, on the other hand, provides with the changes and effects on the winds, because it is closest to the surface. We see that any landform that comes on route of the wind is affecting the direction and the climatic condition of the area, as you have already studied in previous classes, that if there is a hurdle on the route of the wind, then it either causes into precipitation or forms a dry zone, or diverts the direction of the wind. So the maximum effect of friction, that is the surface which affects the movement of the wind, is witnessed in this zone. Moving on to the next feature of troposphere is the gradual fall in temperature that is witnessed, popularly known as normal lapse rate. Normal lapse rate is nothing but a decrease in temperature with the gradual altitude. The mean lapse rate is 6.5 degree Celsius per kilometers, or 3.6 degree Fahrenheit per 1000 feet. Uh, this normal lapse rate is furthermore affected by different conditions as we move upward in the atmosphere. There can be a dry zone, there can be a humid zone. So, with different kind of air parcels that exist in between, the normal rate of temperature fall can be affected. We study them in under the terms of adiabatic lapse rate and dry adiabatic lapse rate and saturated lapse rate. The term adiabatic refers to the rate of temperature change as the air rises or falls without the loss of heat from the air mass. So, the standard adiabatic lapse rate is 3 degrees Celsius per 1000 feet. Dry adiabatic, that is when the column of air is not containing humidity, is 9.8 degree Celsius per kilometers, and saturated lapse rate, when the air column is containing humidity which affects the temperature drop, is 5.4 degrees Celsius per kilometers. So we see that the temperature fall varies not just with the altitude but with the size of the column or the parcel of the air, the humidity content of the air column. The last feature of troposphere is the layer which appears uh, at the top of troposphere. It is a very shallow, a very thin column of air which separates the troposphere from stratosphere. It is called tropopause. As we studied at the beginning of troposphere, the term tropo is for mixed or turbulent area. So here the meaning that would appear is the zone where the turbulence stops. Pause is for halting or for stop. So this is the zone where all the turbulence that exists in the troposphere, it comes to a halt. This is also the uppermost limit of most clouds and storms. Because of its different features and properties, there exists a different kind of wind movement in this zone, which is popularly known as jet streams. In the lower section, that is the troposphere, we found that the temperature decreases with the height. But in tropopause and in stratosphere, the just above layer of tropopause, the temperature rather starts increasing than increasing with the altitude. So this fluctuation in temperature causes the air pressure to uh, shuffle and create these jet streams. They are high speed winds which flow in tropopause and create disturbance in the atmosphere. Other than this layer is more or less very quiet. So this is the end of the first layer of the atmosphere, the troposphere. In the next lecture, we'll study about the next layers of the atmosphere, that are stratosphere, mesosphere, thermosphere and exosphere. Till then, let's study hard. Thank you.